My name is Tasnubatanjali Neha and my ID is 235484553. Today I am presenting my assignment of digital logic and circuits. Here we made a system that name is ICU bed monitoring and control system by defining its work process using the components sensor, counter, comparator, 7-segment display and 555 timer IC. At the very beginning of the system, we calculated the ICU bed capacitance with the help of given parameters. After that, we draw the block diagram and flow diagram for an automated ICU bed monitoring system by using entry and exit sensor, which records the data of enter and discharge patients. Based on the given data from the sensor and sensor of the system, turn on two 7-segment display system that showing either pool or beds available. There is also a counter to accumulate the given data of the sensors that define how many patients are admitted and discharged. Then the comparator compares the output with the capacitance, and based on this, the system takes decision with the help of other segment of the counter. In second, here we use two 555 timer ICs. One is used to explain ICU is full and another is one for beds available. For the second 555 timer, here the calculation. Here P is equals to A plus B plus D plus E plus G into 2. The parameters are according to my student ID. So the P is equals to 44%. Since P is less than 50%, duty cycle is equals to 100 minus P, 100, 56%. Frequency is A plus C plus 5 Hz, which is 12 Hz. Then we know T is equals to 1 by A. That means T is equals to 83.3 ms. Then we know TH is equals to D into T, which is 47 ms. And TL is equals to 36 ms. And we use the capacitor is 50 microfarad. Then resistor A and resistor B is accordingly calculated value 1048 ohm and 308 ohm. Then we justify the additional component. It is highlighted some key points as debounce circuits, edge detector, and comparator for D flip-flop, logic gates, and reset circuits. In question 3, we prepare FSM design with the output A for TH and B for TL. Here TH and TL is equals to 4x. So there is designed a state diagram for the output A and B with the help of 7 state with 1 ms clock difference. Also, we made a state table to define the current state and next state. For SDL code for FSM, where input were are clock and reset. Output A and B also added a parameters according to the current state and begins of state next state. Besides, the push clock edge begin has shown by using loop for reset. In question 4, we add some limitations of task 1 and task 2. There are some limitations in task 1 as in sensor reliability, power loss, less capacity, and no other. In task 2, we have some limitations such as temperature sensitivity, fixed timing, no direct enable, or 555 timer component tolerance. Then we add modification to the system for higher. The current system limitation of 3-bit counter that support maximum count of 8 bits. So we need to increase the counter width from 3 bits to n bits, where 2 to the power n is greater than equal new capacity. And now we add impacts of new modified system. First one, hardware completely increases. Then keypad resistor must be extended. Capacity increases. 555 timer and FSM is reusable. And lastly, power consumption slightly increased. That is all of my presentation. Thank you.